Hello everyone, this is Srihari and in this video we are going to see 3D image generation from stereoscopic vision. So what is stereoscopic vision? Stereoscopic vision is three-dimensional vision produced by the fusion of two slightly different views of a scene on each retina. It is through this vision we perceive depth in 3D world through our eyes. Through one eye we would not be able to successfully perceive depth. How does perceiving depth help? Through sensing depth, we would be able to determine the size of objects and determine the distance of objects from the camera. As you can see in next slide, so this image has different objects and these objects have different sizes and these objects are located from different distances from the camera. So our eyes can easily view or visualize the depth using what I have said before, that is using stereoscopic vision. So the same question arises of how to perceive the depth and the distance of the objects from the camera, that is using stereoscopic vision. But how can we do this in the case of camera, like visual cues for 3D is used for this purpose, like shading, texture, focus or motion. These things can be used to perceive depth. Shading, this is an example of shading, like this image has less shading and this image has more shading. So because of that, in the first image we are not able to perceive the depth that much, but in the second image we are able to get a better view of how the depth is in the second image. So this is an example of perceiving depth or distance of the object by means of varying the texture. So this has one texture, this and this has different textures. So based on that we can see that this seems like a vertical bar, this seems like a horizontal, and this seems like a vertical bar, and we call this we name this as a visual clip because this thing, this cat is trying to climb this vertical wall to reach this horizontal wall. And we can also perceive the depth using the help of focus. Like when the focus is near, you can see all the nearby objects, and just the far-by objects remain blurred, while when the focus is on distance objects, this seems clear and this seems blurred. So this is an example of how to use motion for perceiving depth. As you can see, when the object is continuously moving on different angles, you can see that the depth is continuously changing when we are viewing a single particular point. So stereo reconstruction, as I have explained before, we need two eyes to perceive our depth. How can we do this in the form of camera? Like we have two cameras here and we have all the set of buildings which are the objects to be focused here. So what this happens is the images is being formed due to these two cameras, and based on the images we are able to perceive the depth clearly. So perspective imaging model in 1D. So as you can see, O is the center of projection as it has been explained here. The point B in F 3D object is generated at E behind the lens and also at D before the lens by the similar triangles algorithm. Like this is a similar triangle to this. So based on the fact that these are similar triangles, we are deriving this equation as xi by f is equal to xc by zc. So similarly, like in this thing, this is an object and this is the screen on which the object is the image is being formed, and this is the camera. So as you can see, these also forms similar triangles as in the previous slide. So based on these similar triangles, we are going to determine the xi, yi and f, that is the coordinates of the point which are being formed due to this object at the screen. So xi by f is equal to xc by zc and yi by f is equal to yc by zc from these equations, and from these we derive to this formula that xi is equal to f by zc into xc, yi is equal to f by zc into yc. So 3D from stereo. Here you can see that the third 3D point is being focused to the left image here and the right image here. So we are going to define disparity with the help of these images, like the difference in the image location of the same 3D point when projected under perspective to two different cameras. So this is the image formed by one camera and this is the image formed by another camera. So the point is focused here and the distance between those are generally known as disparity. D is equal to x left minus x right. So in this figure, if for a camera of focal length L and baseline, which is the difference between the positions of two cameras, which has been given as B here, then if the two image points are XL and YL and XR or YR, using the similar triangles algorithm again, we are going to find equations as z by f is equal to x by xl, z by f is equal to x minus b by xr, z by f is equal to y by yl and y by yr, and we using that are going to derive to z, x and y as f star b by xl minus xr which is equal to f star b by d. X is equal to xl star z by f or b plus xr star z by f as it has been given here. Y is equal to yl star z by f or yr star z by f. So this basically demonstrate that with the help of the disparity we are like this is, I mean, these are the images formed. So using this disparity we are going to find, I mean, we have found out the values of z, x and y. So this method of determining depth from disparity is known as triangulation. So these are the two eyes, and when we are choosing I mean, we are generally discussing a perception of human eyes using this slide. So when we are focusing on a nearby object, the angle is found to be A1 and D1 as it has been given here. It is being assumed that it is A1 and D1, and similarly for far the distance object, when being focused, the angle is A2 and D2. So you see, I mean, how we are going to find a relation between this angle and this depth? This is using this formula. D is equal to C by 2 tan A by 2. So depth from binocular disparity. So this is the, I mean, you are viewing from the binocular from this, I mean, this eye and this eye, that is your two eyes. So P is generally a converging point when this point P is at C, which is I mean, when the object is near, then the disparity is found to be positive. When the object is found to be far away, which is being focused, then the disparity is found to be negative. And what is generally correspondence? So let us define correspondence. Correspondence is finding the location of the image of the same point in multiple images. So if the correspondence is correct, triangulation, that is finding the depth from the disparity, it is very much viable, or it can be easily get using triangulation. But how to find this correspondence? There arises a new problem. So the correspondence can generally be found in three ways. Cross correlation using small windows. The first image and the second image, like this and this, depicts how cross correlation is happening. So symbolic feature matching using the segments or corners, and using operators like shift, we are able to define the three matching methods. So consider this image plane, and this is the scene point which is being focused. So binocular stereo, how we are doing that? Like, the basic principle is triangulation. Again, finding the depth from the disparity. So what happens is, for this we need calibration and point correspondence. So what is calibration generally? Calibration is that when we are focusing in a camera, if in camera this has some particular depth, when when in a real world that has some particular depth, that relation between this and that depth or this and that length, then that is particularly known as calibration. And point correspondence. Point correspondence, as I have discussed before, is finding the location of the same point in multiple images. So this point is corresponding point to this point. So next thing, or next step rather, is finding the pixel correspondence, which is the same thing, like pair of points that correspond to the same scene point. So this is the scene point, and what we are seeing here is a new concept called epipolar line. So what are epipolar lines? Matching points of the same object point lie on the corresponding epipolar lines. If three objects, like let us consider some three objects like O1, O2 and O3, that lies from left to right, then the images will also be from left to right on the same epipolar line. So this is known as the ordering constraint. So using these lines and these points, we are we are rather like forming the epipolar plane. So what are conjugate epipolar lines? Like if you consider this as an epipolar line, this is its corresponding conjugate epipolar line. So these are the constraints, as I told you before, like if the object is like this object is on left and this object is on right, the left image, and this is the same, in the same order only these objects appear, but they may appear like in different distances, like as you can see here. So this is the ordering constraint, and you can see that the matching points lie on the corresponding epipolar lines. Matching points are for this blue point and this blue point, which is which is focusing this blue point in the real world. So next we are going to discuss the basic stereo algorithm. What we are doing is take this image and take this image. This is left and this is right image. So take this pixel. So what we are going to do is pick a pixel with minimum match cost. That is the pixel with the minimum difference with this corresponding pixel. So we have found that. So what we have to do to make an improvement on this, we can match windows. We can use correlation or the sum of square distances to improve this basic stereo algorithm. So consider this as an input image. So how we are applying stereo is that we are having a depth map on this. So we are applying a depth map, and based on this we get the 3D rendering as follows. As you can see a better depth perception in this image than in this image because of the stereo vision. So the same thing here, like this is a left image and this is a right image, and using these two images we are finding this finding the depth. So using this video we have seen many techniques of how to generate 3D images using stereoscopic vision, and in general talked about some algorithms which are used in that, and talked about some basic methods like shading, focusing, motion, and some other visual cues. I hope you enjoyed this video. Thank you.